All right, now that we know a lot about oral statistics and we've seen a couple examples, let's do one final example to find the expected value of the mass. So as you can see in the top left up here, the prompt is, let us randomly choose two students from the best class at St. Thomas, Math 313 of course. The height in meters of these students have similar PDFs, and the PDF of each of them respectively is 1 plus 2 over x squared, with the range for x being from the square root of 2 to 2. And Team Sparkles wants to calculate the expected height of the taller of these two students, which would imply the mass of the two. And we are given that the height of the two students are independent. So from Connor's video that we recently just watched, he explained that the PDF for the min is n times 1 minus the CDF to the n minus 1 power times the PDF of y from the range A to B. And the PDF for the mass is n times the CDF of y to the n minus 1 power times the PDF of y from the range A to B. So now that we know these formulas, we can use it to try and solve this problem to see the expected height of the taller of the two students. So in order to do this, we need to find some variables. Let's first define x1 and x2 as the heights of our students, and define y as the mass of x1 and x2. So to find the height of the expected height of the taller of the students, it would be the expected value of y. So we know from previous probability examples that the expected value of y is just the integral from a to b, which in this case is square root of 2 to 2. And then that is y times the PDF of y dy. So obviously from this, we see that we need to find the PDF of y. So for this, we can solve it intuitively and with these formulas. So I'll show you how to do both ways. So first, intuitively, we just have to try and find the PDF. So we know the CDF is the probability that big Y is less than or equal to little y. And from up here, we defined y as the mass of that. So then we just put the mass of x1, x2 in for the variable y. And this would be the probability that both of these variables are less than or equal to y, which we show here, probability of x1 less than or equal to y intercept x2 less than or equal to y. And as stated in the problem, these are independent. So due to the rules of independence, we know that this is the probability of x1 less than or equal to y times the probability of x2 less than or equal to y. And we know that these two x variables are independent and they have the same PDF. They're identically distributed. So we know that this is the probability of x being less than or equal to y squared. So now we have to try and find the probability of big X being less than or equal to little x, which is the CDF of x. So that would be the range from square root of 2 up to x of 1 plus 2 over t squared dt. And if you rearrange this, you just pull the t squared up here, you go 1 plus 2t to the negative second dt. And then when you integrate that, the 1 would become a t, and this part of the integral would become a negative 2t to the negative first. And you plug in the bounds to get x minus 2 over x minus square root of 2 minus 2 over the square root of 2. And we know that the square root of 2 minus 2 over the square root of 2 is 0. So that just gets us x minus 2 over x for the CDF, or probability that big X is less than or equal to little x, so the CDF. And we will use this on the next page. Let me go to page number 2 real quick. So to get the CDF of y, you would do the probability that big Y is less than or equal to little y, which would be the y minus 2 over y squared, as we explained before. So then this is the CDF. So the PDF, you know, to get from the CDF to the PDF, you just have to take the derivative. So if you derive this, you would get 2 to the power rule. That would be 2 times 1 minus 2 over y. Then you have to take the derivative of this, which would be 1 plus 2 over y squared. And then just rearranging, you get 2 times y minus 2y to the negative first times 1 plus 2y to the negative second. And then when you multiply these two expressions together, you get 2 times y plus 2y to the negative first minus 2y to the negative first minus 4y to the negative third. As you can see, these two are canceled to just give you the PDF of y, which is 2 times y minus 4y to the negative third. Or we can use the formula that Connor figured out in his last video if you don't want to take the intuitive approach, which is the formula is right here, n times the PDF of y times the CDF of y to the n minus 1 power. So we know that the PDF, or n is 2 in this case because we have the 2 students, times the PDF with y plugged in, so that'd be 1 plus 2 over y squared, times the CDF with y plugged in would be 1 minus 2 over y. And then in this case, n minus 1 would just be 1 because it'd be 2 minus 1. And then when you multiply that out, it would be 2 times y minus 4y to the negative third. So that is our PDF of y. So then to find the expected value, it'd just be y times that PDF from square root of 2 to 2. You can pull the 2 out because that's just a factor, and then distribute the y's to get y squared minus 4y to the negative second. And then to integrate that, you would get 2 times 1/3 y cubed plus 4y to the negative first. Plug in those values, do some calculations, type into your calculator to get the expected value of y to be 1.791 meters. So that would be the expected value of the mass. And you can do the same steps to find the expected value of the min as well. You can do it intuitively or use the other formula that Connor derived earlier. So that is order statistics. I hope you were able to learn how to do order statistics, what it was, some formulas for it, and ultimately how to use that to find the expected value and probabilities. And I hope you enjoyed it. Order statistics is a very fun topic, so I hope that you enjoyed it as much as I did and decided to stay a math major instead of switching to an English major as Connor suggested.